Okay. Okay. Good evening, everyone. Now I am taking the interview session, second interview session of Ahmad Sheesh. First, I will ask the question. Next, then I will give the feedback. Okay, Ahmad Sheesh, introduce yourself.
My name is Ahmad Sheish. I am from Kerala, Kasaragod district. I have completed my schooling in Prestige International School. I have completed my secondary board of education from Karnataka Board of Education in Mangalore. I have completed my BE in Mechanical Engineering from Barris Institute of Technology, Mangalore. I have scored marks of 82 percentage aggregate. Talking about my family, I live with my father, my mom, and my sister. My hobbies and interests are my hobbies are that I play cricket, I play kabaddi, and I work out in gym. And my interests are to learn new skills. I have already learned cooking, plumbing, electrical works, and mason work.
Last time, what
In
I
all these,
told
I
you,
have
when I tell you to introduce first, only you tell. No, don't tell means in detail hobby and all.
marked.
He also was not. He also will not be
marked.
interested. Only tell your name and where you did the degree and what is your degree percentage and about your family members means like if father's
Okay.
profession, mother's profession, if you have sibling, their profession, and then I think only these many things only he will ask mainly. So only tell there this much. When in my interview he will I give some other interview. He also told that only these many things only you tell me. No, no, don't tell in detail everything because they also will not be having so many interviews will be there. No, so only
Yeah.
okay, again you introduce. Don't tell hobbies and all. Just tell the things. Okay.
Okay.
Hmm.
My name is Ahmad Sheish. I am from Kerala, Kasaragod district. I have completed my schooling in CBSE Board of Education in Mangalore. I've completed my PUC education in Karnataka Board of Education, and I've completed my BE in Mechanical Engineering from Visvesvaraya Technological University in Mangalore. I've
Now
scored
tell.
uh,
Okay. Okay. Yeah. Tell.
I've scored 82 percentage aggregate in my BE in Mechanical Engineering. And talking about my family, I live with my father, my mom, and a sister.
Hmm.
Right.
Then now tell professions means what they will do. That one means they will
Uh,
ask the profession of the means fathers and parents and siblings they want to know. Yeah, tell me.
My
Like that.
my father is a businessman. My mother is a teacher, and my sister is a she is studying in eighth standard.
Hmm. Okay. Then why you want to join merchant navy?
So, talking about why I want to join merchant navy. Merchant navy, I think merchant navy is not just a job. It is a lifestyle which I am craving to live throughout my life since my first PUC education. Working in an engine room with huge machines has always been my dreams, and for that dreams to come true, I have always been working throughout my life. And my qualities and my responsibilities, I know well to take my responsibilities. So I thought of joining merchant navy because of that.
Okay. Then why you want to join Anglo-Eastern?
Anglo-Eastern is a well-established and a great shipping company which has its own ships. Uh, it has good facilities on boards, and having has a good medical facilities which will always reduce the accident numbers on board. And it has its own institution which will give a good training and placement with less waiting period of time. And this is why
Hmm.
I would like to join.
Okay. Okay. Okay, Shubham. What are your strength and weakness?
So my strengths and weaknesses are I always work hard and always make a good plan before executing my plans. I always think once or twice the things that I have decided. I never give up on whatever the condition it is until it's all over. One such example I would like to share is in a kabaddi match. I was the captain of our kabaddi team, and our team wanted around 5 to 6 points, and there was only 2 minutes left.
Hmm.
And I could easily score that 6 points with the good plan and techniques used. Even our coach was surprised by the way we played.
Hmm.
Other than this, I have a good captainship quality, which I always lead my team throughout. And during my schools, I was the captain of a sports team and also other cultural teams. And I always respect my seniors, and I always have great leadership. I respect my seniors and always obey the rules and regulations and work according to what my seniors will direct me to work. Apart from this, I I am self confident.
Hmm. Or you can add this also, means like you gave the example, right? Means like 6 points was there, means you had done that, means like you never give up attitude. So you can add up after that. I think this attitude will help in this onboardship also, so that this never give up attitude will helpful in the onboardship, where I can make wait. Let's start the technical discussion. Uh, Draw the centrifugal pump and explain how the discharge pressure is created in the centrifugal pump. Yeah, it is proper. And show that in the impeller, no, how in one of the impeller, means top side, you show the arrow that it is coming outside from the impeller from inside, like that. Okay. Hmm. Huh, yeah, and from the impeller, means like from impeller blade it is coming out, like that you show one arrow. Yeah, now it is proper. Yeah, tell me how the discharge pressure is created.
When the motor rotates, the shaft which is connected to the motor rotates the impeller.
Hmm.
As the impeller rotates, the water inside the casing gets displaced radially outside.
Hmm.
This causes the vapor pressure. This causes the vacuum inside the casing. When vacuum is created, there will be pressure difference inside the casing and at the reservoir. This causes suction at the impeller eye. Hence, the water gets sucked through the footwall strainer and the suction through the suction pipe into the impeller, and the suction is created at the inlet. When suction is created, the water enters to the suction pipe through the footwall and the strainer, and it gets into the casing through the impeller eye.
Hmm.
Now, when the impeller rotates, the water gets displaced radially outwards towards the discharge through the guide vanes and the design of the volute casing. Design of the volute casing is such that it increases its area through the discharge side. Hence, kinetic energy of the impeller is converted into the pressure energy through the discharge side, and hence we get discharge at the impeller at the discharge side.
Yeah, everything is proper. Only one correction you do. When the fluid enters into the eye of an impeller, then then the impeller will exert the kinetic energy and on the fluid. Then due to the centrifugal force, the fluid is pushed out radially outwards, and comes out through the guide vanes and enter into the casing. This much only you add. Okay, then the
First, it will
casing is designed in such a way, then and all it is proper. Only what is happening inside the casing, only this much correction you do. Okay. I
can
will,
you tell
hi.
once again?
Yeah, I will tell. I will tell. The kinetic see, whenever the fluid enters into the eye of an
Mhm.
impeller, it will then impeller exerts the kinetic energy on the fluid. Okay. Impeller exerts the kinetic energy on the fluid, then fluid will then because of the
Centrifugal force.
centrifugal force, fluid is pushed radially outwards, and and fluid will comes out through the guide veins, and it will comes out through the guide veins, then enter into the casing. Then later part you are correct, only this sentence you add.
Then
Okay.
when will the pressure energy be
Yeah,
built?
see, when it will
After the
see when it will enters into the casing is designed in a such a way that it is increasing the volume towards the discharge side of the pump. Okay, so because of this, the kinetic energy which is imparted by the impeller is converted into the pressure energy.
due to the increasing area of
अदरवाइज
the
हाँ,
casing.
हाँ ये इन एरिया मत बोल, वॉल्यूम करके बोल, एरिया बोल के एक बंदा रिजेक्ट हुआ
Okay.
है, वॉल्यूम करके बोल. Then he will ask how it is area, it is not a two dimension, the pump is a three dimension, how you can say the area, he will ask. Okay, don't tell that. Volume you told, volume you tell. And when fluid comes out through the casing because of the design of casing, the वो होता है, मतलब kinetic energy of the fluid is converted into the pressure energy. Then this is how the discharge pressure is created in the centrifugal pump. This much only you tell, this much only I also told, he accepted this answer. Okay, means okay Ahmed, tell me what happens if the air enters into the centrifugal pump.
If air enters the centrifugal pump, there are two problems taking place inside the centrifugal pump. The first one is, since air is a compressible fluid and liquid is an incompressible fluid, when the impeller tries to push the water towards the discharge side, it won't take place because air is a compressible fluid, and because of this, the impeller will run dry, and they will be heating problem, or heating takes place in the seals, and it might damage the motor. The second reason is that it might damage the pump. The second reason is that the density.
Okay Ahmed, can you repeat your answer.
Yes. In a centrifugal pump, when air enters the casing, the when air enters the casing, the air is a compressible fluid and the water is an incompressible fluid. And when the impeller tries to push the water towards the discharge side, it can't apply the force because of the air being compressible. Hence, what happens is the casing runs dry, or just it turns inside the water inside the casing, and water cannot be discharged through the discharge side. The second reason is that density of the air is 1000 times lesser than the water, and hence it occupies less space hence it occupies less space, and pressure cannot be built inside the casing, which will result in the discharge of the water. And in this case also, the impeller will rotate dry, or churn the water within the casing without giving the discharge. Hence, it might also damage the motor windings.
Hmm.
Enough, right?
Yeah, this much is
That much
enough.
is correct.
Huh. Means only mention whenever the air is compressible, mention that it cannot push the water ahead. Then when will suction capacity will decrease, whenever then you tell water density is 1000 times more than the air density. If there is a water, it can suck the more, suction capacity will be high. Once the air will enter, so the suction capacity of the pump will decreases the 1000 times, because the density of the water is 1000 times more the density of the air. So then you can so this is the two effects you already told. Then the third one is, because of this the efficiency will get decreased, efficiency of the pump will get decreased, and motor winding can get damaged. Yeah, only these four if you tell, it's fine. This is enough. Okay.
Yes.
Then can you tell gear pump working? Can you draw the gear pump and explain how the discharge pressure is created?
That's it.
Okay. Okay. Other than that, it is correct. Yeah. Yeah. Explain how the discharge pressure is created.
First, I will be telling the parts of gear pump.
Hmm. Okay.
Okay. in the gear pump, there are two main gears that are used. First one is a driver gear, which is connected to the prime mover. The driver gear is interlinked to the follower gear, which when the driver gear rotates in a clockwise direction, the follower gear rotates in a counterclockwise direction. When the when the two gears come mesh together, there will be increase in the volume, and a vacuum will be created at the inlet side of the gear pump. This will cause a negative pressure, and sucking of the water takes place through the inlet side. Once the water gets sucked, uh, it occupies the spaces in the slots of the gears, and when the gears rotate, this water is pushed towards the discharge side. And in the discharge side, because of the decrease in the volume of the gear slots, the pressure is build up, and hence discharge takes place inside the gear pump.
The gear, when the gear gets out of the mesh, then volume increases and pressure decreases, then the suction will takes place. Don't tell ulta.
In the PDF, it was
I'm
like that. I'll
yeah,
change
yeah,
that.
I'm sorry. I am going to edit it, but
Uh,
you tell that. Then later I cross checked. I want to edit it. I will edit it today, and I will send again. Okay.
when the
When the
gear
gear
comes outside the mesh,
out of the mesh, the volume increases and pressure will decreases. Okay.
at the discharge side, when the gears come inside the mesh,
Come in the
the
mesh,
volume
the volume decreases and pressure increases, so the
decreases
discharge
and
will
pressure
takes place.
increases.
Yeah, that thing
Okay.
later I got to know. I will edit it. I'm so sorry for that. Okay. Huh. Okay, then okay, tell VCRS, vapor compression.
Your network is slow, or mine is slow, I guess.
uh, Mine is proper. I using the mobile data.
Ah,
Okay, explain the working of VCRS cycle, refrigeration cycle.
VCRS. Low pressure, low temperature, low pressure, low temperature, dry saturated vapor refrigerant enters the condenser. In the
Compressor,
condenser,
compressor,
the
right?
dry saturated
Enters
compressor,
into the compressor.
in the enters into the compressor. From the compressor, in the compressor, the dry saturated vapor is converted into the compressed air, that is high pressure and slightly low temperature, which then turns into the superheated vapor. In the
Slightly low
condenser,
temperature of how you are
uh,
telling it is going. See, when saturated vapor enters into the compressor, the compressor will
I'll tell from first. I'll tell from first.
Okay, okay, tell me.
I'll tell from first. Yeah. Dry saturated vapor, low temperature, low pressure, vapor refrigerant enters the compressor. In the compressor, the dry saturated vapor is compressed to high pressure, high temperature, the high superheated vapor, and it enters to the condenser. In condenser, there is a continuous flow of seawater, which cools the superheated vapor and converts it into the high pressure, slightly low temperature, saturated liquid refrigerant. This is then fed into the dryer. In dryer, there is a silica gel, which helps in absorbing the moisture content. Once the moisture is obtained, this saturated vapor is then sent to the thermal expansion valve. In the
Saturated
thermal
liquid.
Saturated liquid is sent to the thermal expansion valve. In the thermal expansion valve, there is a orifice where sudden drop in the pressure takes place. As the pressure drops, the temperature also drops, and now the refrigerant is in the form of liquid vapor mixture, the saturated liquid vapor mixture. This saturated liquid vapor mixture is then fed into the evaporator. In the evaporator, the liquid vapor mixture absorbs the heat, and phase difference takes place from the liquid vapor mixture into the vapor refrigerant, uh, and then there is a sensing bulb in the evaporator, which senses if the temperature is above the above the maximum temperature, or if it is below the minimum temperature. It sends the information through the capillary tube to the thermal expansion valve. In thermal expansion valve, when it gets the signal, it regulates the size of the orifice according to the signal it gets received. If the temperature is high, the orifice will be opened more, and if the temperature is low, the orifice will be closed
constrict.
further.
हाँ,
They
क्लोज और constrict दोनों सेम है, मतलब कुछ भी बोल सकते.
constrictable. Therefore,
क्लोज ही बोल दो. कॉन्स्ट्रिक्टेबल इज रॉन्ग. कॉन्स्ट्रिक्ट्स करेक्ट है. नहीं नहीं याद आया तो इट विल द डायमीटर ऑफ द ओरिफाइस विल बिकम स्मॉल. ऐसे बोला तो भी चलेगा. ओके.
uh,
हाँ, उतना ही.
then the
हाँ
process उतना ही.
हाँ. देन हाँ, what is the temperature of the evaporator in domestic refrigerator?
The temperature at the evaporator depends upon many factors. One such factor is the type of refrigerant we use in the refrigeration process.
फिर मैन्युफैक्चर मत बोल ना, इट डिपेंड्स ऑन द टाइप ऑफ रेफ्रिजरेंट वी यूज करके बोल दो.
ठीक.
ओके. देन व्हाट आर बॉयलर माउंटिंग्स? लिस्ट आउट द बॉयलर माउंटिंग्स.
Some of the boiler mountings are pressure relief valve, safety valve, water level indicator, a blow off cock, steam stop valve, feed check valve, fusible plug, low level water indicator, scum valve, and air vent cock.
प्रेशर रिलीफ वॉल्व है कि नहीं मालूम नहीं. सेफ्टी वॉल्व है. सेफ्टी वॉल्व. प्रेशर रिलीफ वॉल्व है और नहीं, आई डोंट नो अबाउट इट.
Okay.
Safety valve it is there. Whether safety valve is called as
And
pressure relief valve, I am not sure.
one doubt I had
Yeah.
in that guy is right, Gyan, your
हाँ
friend.
हाँ.
One of his interview.
Hmm.
Huh?
Yeah, no, tell me. Yeah.
Not your friend.
No, not like that.
I
Yeah, tell me.
one of his video I checked. In that he was telling some extra mountings of boiler, not boiler, auxiliary engine, I guess.
What are
Three
you?
something he told extra. Should I add that, or this is enough, right?
In boiler mountings, it is totally it is 10. It is there. If you add the fusible plug, then there is a 10. But people will avoid telling the fusible plug
No.
because its working is it is not known properly like that. So people will avoid telling fusible plug. So they will tell only 9. Means a safety valve. I will tell.
Not
So.
in
Not in boiler mounting.
not in boiler. No. In this, I'll tell 1 minute. In auxiliary engines, he said extra fuel oil leak of alarm.
Fuel oil leak alarm.
He said something like that.
Then next question. Explain safety device of refrigerator. VCRS safety devices.
In refrigerator, there are low cutoff pressure valve, high HP cutout valve, low pressure lube oil valve, bursting disc used in the condensers only
Low
if used,
pressure
and
lube oil. See, lube oil low pressure trip it is there.
lube oil low pressure trip, bursting disc used in between the inlet and exhaust valve, water current valve in condensers.
Inlet and exhaust valve.
Not inlet and bursting disc in between the inlet and exhaust manifold.
Oh, okay, like that. Proper.
relief valve,
Hmm.
then relief valve, master solenoid valve, oil
Hmm.
heater.
Hmm.
Yes.
Yeah, that much only. Okay, what is the function of oil heater? What it does?
In the lube oil in the crankcase should always have a should always have a standard temperature. If the temperature of the lube oil goes below or goes below, there will be freezing takes place, and the lubrication activity inside the crankcase cannot be done as usual. Hence, boiling of a lube oil is required once the temperature is reduced below the minimum level.
Lubrication part. So wait 1 second. Uh,
Mm.
uh, then compressor safety devices. You remember?
Uh, some of the compressor safety devices are relief valve, bursting disc, fusible valve, air high temperature trip, water high temperature trip, water no flow trip,
In compressor there is no relief valve.
more, no relief valve.
Bursting disk you have in compressor. Correct no?
Uh,
Yeah, lube
this
oil.
I had done some notes before. Before I had done some notes.
Be
So in
careful
that I got
while
from Google.
mentioning the relief valve and bursting disk. You should be very specific. I told you no that one. So lube oil, low pressure alarm and trip, bursting disk, fusible plug, motor overload
Bursting
trip,
disc, fusible plug.
water no flow trip, or water high temperature trip. Only these many are there.
Yeah, moisture drain valve and air high temperature trip, that is not needed.
Moisture.
Moisture drain valve, that is there. One I found it from Google before your notes.
Okay.
I got.
If you got that, you can tell. Means you should know what the function it is also doing. Means
Uh,
whatever I said no in my notes means there is an explanation also with explanation I have told. So you can read that explanation
yeah.
and you can mention it. If any question asked on that, you can answer it. If you mention other
Okay.
than this, you should know explanation as well. If interviewer ask related to this, you should be capable to tell like that. Then
Okay.
only you tell that. Otherwise, don't tell. You can
Uh,
mention these many.
okay.
In these many only he will ask one of them. Then that is fine, no? If you
Okay.
know that. Okay, what is
Uh,
Faraday's law?
Faraday's law states that whenever a conductor is placed in a varying magnetic field, electromotive force is induced. Electromotive force is created,
Hmm.
and if the conductor is a closed circuit,
Hmm.
then the induced current is called as then the current induced is called as induced current. Faraday's second law of motion states that when a coil produces an electromotive force, it is directly proportional to the flux produced by it.
Hmm. Hmm. Yeah, flex means correct. Hmm. Okay. Then do you know Archimedes principle? Yeah, tell me.
Archimedes' principle states that whenever a body is wholly or partially immersed in a body, the body tends to be lifted up by a force equal to the weight of the water displaced,
Hmm.
and the weight of the water displaced is called as uh, force applied because of the weight of the water displaced is called as buoyancy.
Hmm. Buoyant force.
Buoyancy.
Huh. Then difference between two stroke and four stroke.
Two-stroke engines for one power stroke, one revolution of the crankshaft is needed. For in four-stroke, for one power stroke, two revolution of the crankshaft is required.
Hmm.
In two-stroke engines, the flywheel used is lighter than the four-stroke engines.
Hmm.
In two-stroke engines, the for the inlet and exhaust of the fuel, inlet and exhaust ports are used. In four-stroke engine, inlet and exhaust valves are used. In two-stroke engine, the manufacturing cost is high. In two-stroke engines, manufacturing cost is less because the engine is less bulky. And in four-stroke engine, the manufacturing cost is high because the engine is heavier than the two-stroke engine. A two-stroke engine provides more power to two-stroke engines have a high power to weight ratio. Four-stroke engine have less power to weight ratio. Two-stroke engines consume more fuel. Four-stroke engine consumes less fuel. The thermal efficiency of a two-stroke engine is less as compared to the thermal efficiency of the four-stroke engine. The volumetric efficiency of the two-stroke engine is less as compared to the volumetric efficiency of the four-stroke engine. Two-stroke engine have two-stroke engine have a longer length of strokes than the four-stroke engine.
Hmm.
Two-stroke engines are used on two-stroke engines. Yes, that's it.
Hmm. Okay, this much is fine. And what you told that engine is bulky or something, I didn't get it. It's like what, two-stroke engine? What you told that?
Two-stroke engines are cheaper in price because the engine is bulky and not so complex.
This point you don't tell. I don't
In
know.
four-stroke, the engine is heavy. Uh,
Means I'm not sure about it. So other things are fine. Hmm. Because the two-stroke engine is bulky, the cost is less. I don't get it. Means so better you don't tell. Other instead of this, other points are very fine. No, so you can tell that. Okay.
then in this point correct? Like two-stroke engines are crosshead type engines,
Crosshead time.
and
Crosshead it is there because to connect the upper
four, four,
piston. Yeah.
four-stroke are trunk type engines.
Yeah. This you can tell. Because the crosshead is because the connecting rod is so long, no, so you cannot make it. So crosshead is used to connect the both thing, means upper crankcase and this one
In
above part.
crosshead engines, piston rods are used.
Yeah, means it is very long, no, means
Where
in four stroke
uh,
connecting rod is
uh,
small compared to the two stroke. So in so it can directly connect to the crankshaft, means the crank. But in two stroke it is very big, bulkier, no, so you want to use the crosshead. So because of that, so it is fine. The rest and all is fine. Only that because it is bulky, cost is less. It is, I don't think it is logical, or I don't know about it. So uh, then difference between the centrifugal pump and a reciprocating pump.
Centrifugal pump works on the rotodynamic principle. Reciprocating pump works on the positive displacement. Reciprocating pumps work on the reverse piston principle. The centrifugal pump have a moving part as the impeller. The reciprocating pump have the piston as a moving part. In a centrifugal pump, priming is required. In a reciprocating pump, priming is not required.
Hmm.
Centrifugal pump have high discharge and low pressure. Reciprocating pump have high pressure, low discharge. In centrifugal pump, the discharge is the flow is in constant rate. In reciprocating pump, the flow is not constant. Flow
Hmm.
keeps fluctuating. Centrifugal pumps can pump only the less viscous fluid. The reciprocating pump can pump only
Any kind of
high
fluid,
viscous fluid,
not necessary
any
high
kind
viscous,
of
any
fluid,
kind of fluid it can pump.
uh, any kind of fluid.
Hmm.
Then centrifugal pump applications are used on the ships like seawater pumping, ballast pump, etc.
Hmm.
Reciprocating pumps are used in sludge pumping, etc.
Hmm. Hmm. Okay. Uh,
Uh,
because to pump the sludge we use the gear pump and the screw pump to sludge, to pump the sludge and all.
sludge
So I
pump.
don't know exactly the reciprocating pump will also does that, because sludge is very highly
So
viscous, na. So I am not sure about
applications, I won't say. Application, I won't say.
yeah, better you
Instead of
don't say.
that, efficiency of centrifugal pump is high, then efficiency of reciprocating pump is less.
Hmm.
Then maintenance of centrifugal pump, maintenance of Centrifugal pump is less, maintenance of reciprocating pump is high.
This you can tell. If you are not sure if the complicated things, no, you better don't say. Other things, whatever telling, in that only the 7-8 points over, no,
Yeah, yeah.
then that is more than enough. Okay. Uh, so
Like more this he will do. Cross questioning more he will do. Like for you, how he did.
no, he will don't unless you tell something wrong. No, he will not cross question. If you tell something wrong, no, uh, means if you tell something wrong, then he will cross question. How it is like that, like that he will ask.
This oceans, canals, then ports.
No,
He
no,
such questions he'll ask.
those questions he will not ask. Whatever I asked, no, no, only these questions only he will ask. Briganza sir means
If other two sirs are there, right?
ha ha
What about them?
other tools.
They'll ask.
Wait. Yeah, in the non-technical side, you can improve like in the introduction part. You should tell only means like your parents' name and your siblings, your parents' profession and sibling if there is any. You can tell the profession, and you should tell only your name and where you came from, and you should mention the aggregate percentage of the degree. So that much you improve. And in the and another thing where you got wrong is you can I gave you already the feedback of the centrifugal pump, right? You can add that sentence. And in the gear pump, make sure that suction will takes place, because whenever the gear is out of the mesh, at that time the volume will increases and pressure will decreases, then the suction will takes place, and that part. And other than that, you told everything correct. There is nothing wrong in it. Okay. Okay, bro. Okay. Thank you, bro. Okay.
Next, you will conduct anytime soon for me.
You text me. I will let you know at that time.
Uh,
Okay.
no, you tell one day. That day I'll be ready. Like how
Yeah.
much you keep. You
Okay.
tell
Okay.
one day.
Okay.
Now itself will say.
I will
I,
let you know. I will let you know in message. I will
okay.
text you. Okay. Bye bye.